Lesson 7.5, we're going to use a tangent ratio to find indirect measurements. A trigonometric ratio is a ratio of the lengths of two sides in a right triangle. The ratio of the lengths of the legs in a right triangle is a constant for a given angle measurement. It is called the tangent. Okay, so if I want to find the tangent of A, it is the opposite side over the adjacent. So the tangent of A would be the length of BC over the length of AC. The great thing with finding tangent of B is that when it's the opposite over the adjacent, which would be AC over BC, is that it is the inverse of the tangent of A. So we're going to find the tangent of A and B. We're going to write our answers as a fraction and as a decimal rounded to 4 decimal places. So A, opposite, adjacent. So the tangent of A is 3 over 4, which is 0.75. The tangent of B is the inverse of that, and as a decimal is 1.333, the 4 decimal places. So the tangent of A, opposite over adjacent, oops, and the tangent of B would be the inverse. Okay, so we're just going to set this one there. We can use this to find some missing side lengths. So write the relationship to the angle. And if the variable is in the denominator, we divide. And if it's in the numerator, we multiply. So the variable is in the denominator. They just change places, so we divide. And we go to 1 decimal place. So label in relationship to the angle. Tangent of the angle is the opposite over the adjacent. Once again, it's in the denominator. So we divide. And this last one, opposite over adjacent, has our variable in the numerator. So when it's in the numerator, we multiply. Okay, so we're going to skip these. and go to the bottom. Again, label your parts in relationship to the angle. It's in the numerator. We multiply. Okay, we're going to skip this one and go to the last one. Tangent of the angle equals the opposite over adjacent. It's in the denominator. So we divide and go to 1 decimal place. We can expand this a little bit further and find the area. And in order to find the area, the first thing you need to do is find x, then use 1/2 base times the height. So how do we find x? We use the tangent. So here we have opposite adjacent. It's in the denominator. Then use your area formula. Doesn't matter which one's the base, which one's the height in a right triangle. And we're going to do the last one. Opposite adjacent. It's in the numerator this time, so I multiply. And then your area formula. Okay, and finding the perimeter, first thing you're going to do is find the missing leg. So we'll call it x. And then you'll find the hypotenuse by using the Pythagorean theorem. This is opposite and adjacent, so x over 49 is in the numerator. And then to find y, it's the square root of the sum of those two legs squared. And perimeter is just adding those three lengths together. And in the complex figure, it already tells you in the directions which one to find first. We have a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, the legs are the same. Or you could do the tangent 45 equals opposite. I'm using that 45. Opposite over adjacent. So now I have y. That's the opposite over adjacent. So the tan of 28 equals 82 over z. It's in the denominator. So we divide. And we get 154.2. And this ends the lesson.